Okay. No, I'll just leave the same picture up. I want one of you guys, to show me. There might be some places where my guess would turn out to be terrible with relation to Newton's method. Where could I guess, if I guessed the root, if I made an accidental bad guess, what could happen?
You could just put here.
Okay.
Right in the middle of the roots.
Then you do the tangent line. It's parallel to the x-axis.
Okay.
And you can't do anything.
Okay, so there's one problem I could have. That I just accidentally guess.
Halfway between the roots.
It's not necessarily halfway in between the roots, but it's it's a place where the tangent line
will be parallel.
Will be parallel. So why did you say it was halfway in between?
Well, for quadratics, this point is the x value of this point is halfway.
For quadratics, it is, but for general functions, it might not be. In fact, you could have a very wiggly function, and that the tangent lines aren't necessarily right in the middle of wherever the roots are.
Yeah.
The flat tangent lines.
Well, if you had a point.
Okay, so that's one problem that could happen. So I just make a bad guess, a super unlucky bad guess. What's another problem that you think might be able to happen here?
Well, I was going to say doing it within this range, but I guess you can still make that work.
Okay, yeah, maybe.
Or maybe another problem would be where if you guessed where the function was near vertical.
Oh, very good. If the function was vertical at some point, what would happen? How would Newton's method work? Like, let's just pretend it's vertical there.
Well,
if it's vertical, then the tangent line would just send you back down to where you were.
Started with.
All right.
So that's the same kind of problem that comes up here.
Okay, so if I have a horizontal or a vertical tangent line,
yeah,
I can have a problem. I'm going to show you one other problem that I need to draw a slightly new graph for. Okay. Now, I know there's a root here, or I'm pretty sure there's a root here. And let's say in this graph, I pick this point.
Oh.
Okay. What happens to my Newton's method procedure here? Can you see where the tangent line goes?
Well, tangent line. This. That's might send you farther away.
Well, actually, it's interesting that the tangent line hit exactly right there. Okay, so
the tangent line crosses another point on the court.
Well, remember, I'm only following the tangent line down to the axis.
So then that just leads you into this problem.
Okay. So in this in this amazing example, the tangent line actually hit a point, hit an x value, and then we went down to the function. And what was the problem with the function there?
And it's this. The tangent line's parallel.
Yeah.
But the other problem that I saw from this graph is if this root, or this point went over to this root.
Right. It might not go to the. You might be near to this root, but just because of the shape of the tangent line, let's say it ended up being a little more. Let's say maybe I picked up here, so it skewed a little bit more over here, like that.
You might find the other root.
I go here, and now the tangent line sends me over here, and then I go up, down, up, down, up, down.
Then you sort of gravitate toward that root, even though you're much closer to that root.
Right. So you can't. You do have to be a little bit careful with Newton's method, in that there's no guarantee. It looks like from our first example that it works really well. Yeah. But actually, there's no guarantee because there's a lot of little weird things that might happen. So that's kind of interesting. So let's see. Why don't I draw a picture like this, and I'm going to have you both independently pick a point and then show me draw the tangent lines and show me what Newton's method is. Okay.